Question number 9. At its melting temperature, molten zinc is poured into an iron mold. The molten zinc becomes a solid without changing temperature. Outline why a given mass of molten zinc has a greater internal energy than the same mass of solid zinc at the same temperature. Okay, so the key here is to know the definition of internal energy and how it relates to temperature and melting. Okay, so internal energy is the sum, is the sum of the kinetic energy and potential energy of the particles in a sample. Okay, melting increases the potential energy of particles, and it does it by breaking the bonds between particles. So as the substance turns from a solid to a liquid, the bonds between the particles are broken. And melting increases the potential energy of particles without increasing the kinetic energy of them. The kinetic energy. Maybe we can say then, thus, the internal energy increases even though the temperature doesn't change. And that's because the temperature depends on the average kinetic energy of the particles. Okay, I think we've done enough to get 3 marks there. Okay, B. The zinc is allowed to cool in the mold. The temperature of the iron mold was 20 degrees before the molten zinc, at its melting temperature, was poured into it. The final temperature of the iron mold and the solidified zinc is 89 degrees. And we're given all that information and use the data to determine the specific heat capacity of the zinc. Okay, so we've got 3 bunches of energy here. We've got the energy that the zinc loses in turning into a solid. Sorry, that the zinc gives off in turning into a solid. And we've got the energy that it loses in cooling from 420 degrees to 89 degrees. And the sum of those two should be equal to the energy that the iron gains in heating up from 20 to 89 degrees. Okay, so maybe what we'll do is just work out the losses first. And that is solidifying that's ml, which is equal to, we've got 1.5 kilograms of it, and L is 113,000. That's times 10 to the 3. And then we've got cooling. That's mc delta T, which is, what is it, 1.5 times C times, solidifying, really it's a loss, so we're going to make both of these negative. Or actually, no, let's leave it as it is. Okay, the cooling is 1.5 times C times the final is 89 and the initial was 420. So those are both heat removed, and the gain of the iron is MC delta T, so heating, and that is 12 times the specific heat capacity of iron is 440 times delta T, which is 89 minus 20, which gives us, let's work that out, 12 times 440 times 89 minus 20 is 69. 364,320 joules. 364320. This one here is equal to 1.5 times 113 times 10 to the power of 3, 169500. Oops, 169500 joules. And the cooling one, the one with the unknown, 1.5 times 89 minus 420. Oops, I need a bracket there. 1.5 times 89 minus 420 equals negative 469.5. What was it again? 0.5 times C. Okay, so we know that the amount of heating that the iron experienced came from the energy lost in solidifying and cooling of the zinc. So C, well, in fact, so I can just write that out just to make that whole thing make sense. This is probably the trickiest question in this section. So we've got 169,500 plus 469.5 times C is equal to 364,320. The reason I've got plus here is that I know that the two losses, both of these are losses. Both the solidifying and the cooling are losses. So regardless of what sign I ended up with there, I know that they're both losses in energy. And I know that those losses have to add up to the total gain of the iron, which is 364,320. And so here we can just rearrange that to find C, and we get C. Let's just do the final calculation in this little corner. C is going to be equal to 364,320 minus 169,500. Both of those, that all divided by 469.5. So let's see what we get here. Let's move this calculator over. 369,320 minus 169,500 is equal to, and then we divide that by 469.5, which gives us 426. 426 joules per Kelvin per kilogram. So that's how we work out the specific heat capacity of the zinc, and that's worth 4 marks, justifiably. There's a lot of scope for getting the signs confused, but you need to kind of use a bit of common sense. Both of these two things here are losses. This is the only gain, and so if we add up those two quantities, then we should end up with this quantity. Okay, I hope that's clear. Let me know if you have any questions.